Thank you for joining me today. I am Mr. West, and we're going to be talking about a geometric concept, reflections. This is section 9.2. Let's go ahead and get started. This is an extension from translations and geometric transformations. So if you haven't already checked out section 9.1, I would recommend it. Obviously, you can see in real everyday situations, reflections. If you look at a mirror, if you see the reflection of the sun off the water, those are examples of reflections, but we're going to learn the geometric properties in this video. What is a reflection? Well, a reflection is a mirroring of a shape across a line. Okay, so it's the mirroring of a shape across a line. And we're going to flesh that out a little bit more with some of the properties of a reflection, but that is the basics of it. Now, let's look at this first example. We have JAM, it's a triangle, and let's say that this is our line of reflection. So I need to change colors here. This is our line of reflection. So this is essentially the mirror, okay? So if this guy were looking at himself in the mirror, what would appear in the mirror? Well, the closest point here is M, if you see here. So this needs to be point M right here. But we're going to call it M prime because it's been transformed. So you can see here that this right here, there's a distance here, and it travels the same distance through the mirror to that side. Okay, next property, or excuse me, next vertex, we have A up there. So A up there, okay, so if this guy was looking at himself in the mirror, there's the line from the line of reflection, the distance from the line of reflection, and then this goes to point A right there. So that maps it, but this can't be A because there's already an A, so that becomes A prime. And consequently, we have, this is going to be J prime for the last one. And hopefully you guessed it, we're going to have this distance, whoops, right here is going to be the same. Now, I just gave it away, but you're going to notice here that if we have a line of reflection, these distances are the same. So this distance right here is going to be the same as it is right here. This needs to be equidistant. Equidistant. And it's one word, but I kind of split it up because I want to show you, whoops, I didn't want to do that. There we go. Try this again. Okay, this is equidistant, across the line of reflection. So that is the key to reflections, is that as you reflect it, it is equidistant from the line of reflection. And that's one of our properties here. So our first property is that points are equidistant. So points are equidistant. We have another example right here to the right. We have ABC, a triangle, so we can go ahead and plot our new points. This is going to be C prime, this is going to be B prime, and this is going to be A prime. Now I've already drawn some lines for you. You can tell that we're reflecting across line M. This is our line of reflection. Okay, so that is the line of reflection. Then these points need to be equidistant. Oh, I forgot to say that. Equidistant from line of reflection. So we're looking here, and these 2 points would be equidistant. So these two, we kind of drew it up earlier, but those 2 lines need to be the same length. They need to be the same distance away. Just like these distances, we'll make it 3 this time, need to be the same length. And then obviously C is right on the line, so that is the same length there. The other property for reflection is the line of reflection. Oops, that's not how you spell reflect. That's reflect. Reflection is a perpendicular bisector. All right. So it's a perpendicular bisector. That means that if we were to draw this line right here, okay, as this blue, we've already kind of drawn it. Let me just draw this line. Okay, so if we were to draw this line, and obviously we already have the line of reflection going here. Okay, just like this. It just means that that's going to be a right angle, and it bisects it. So we already drew that it's bisected here and here. It's bisected. And it is perpendicular. So those are the two other features of a transformation using reflection. Now, we already talked about notation for translations, and we talked about how we use the big T, and then we use the little bracket, and then the parentheses. Well, reflection is a little bit different, but still the same principle. So reflection, this first part, let's use pink. This first part, this R stands for what type of transformation it is. So that means reflection. Big R means reflection. Okay. Now, this M means this is the line of reflection. So it can either give you, A, the name of the line, or B, and this is more important in my opinion, it can give you the equation of the line. It can give you one of those two things for the line of reflection, okay? This here is the pre-image. So after it gets transformed, it's going to turn into, let's change the color. I'm feeling this light pink, salmon color maybe. A prime, B prime, C prime, and that is going to be the image. Not post-image, just image. Okay, so that's our notation. Now let's go ahead and put it into an example. You can reflect anything. You can reflect points, shapes, whatever. So here we have our first example. Point P has coordinates 3, 4. What are the coordinates of big R, y equals 1, P? Okay, as you can see, we got a couple things going on. One, we see that we are trying to do a reflection, the big R. We have our line of reflection, y equals 1, and we're going to talk about that in just a second. Then we have our pre-image. So clearly we're looking for our image. Now, the other thing we know about P is we know that P, which is designated here, oops, don't want it that dark, okay, is this shape, this coordinate, whatever, okay? It gives us some information about point P that we can use. All right, so that is point P. Now, step one, what is the process we're going to be using to reflect this? Our first step is going to be plot the shape. Whatever shape we're given, we need to plot it just to get a visual of it. So we're going to have point 3, 4. We're just going to find 3, 4 on our graph, 3, 4. And I'm going to label it 2. So I have point P right there. Step 2, we've already plotted the shape. Now we need to draw line of reflection. Talking about reflection so much, it's reminding me of Mulan. If anyone knows that song, great one. Draw the line of reflection. Who is that point I see staring straight back at me? Point P, I need to find the line. Ah, I found it. There it is. There's my line of reflection. What color do I want to use? I'm feeling this light purple for my line of reflection. Okay, so this is my line of reflection. Y equals 1. Now, if you remember back, this is from a previous chapter, chapter 3. We have y equals mx plus b. So if it's y equals 1, technically that is the same as y equals 0x plus 1. So our y-intercept is going to be 1, and our slope is going to be 0. That means we go slope equals 0. That means we go up 0 over 1. Up 0 over 1. Rise over run. Okay, just in case you're running. 0, 1, 0, 1. Okay, it's a horizontal line. And I like to do a dotted line for, let's see if I can get the new extension. Notability is a great feature. I'm not sponsored by Notability, but I'd love to be. Notability has a really cool feature with lines now, I'm pretty sure. And there it is. See how you can go and make it dotted? Look at that. Thing of beauty. So that's my line of reflection. And now, what's my third step? I have my point, I have my line of reflection, and now I actually have to do the reflecting. So we're going to use these processes. First, we're going to have, we know that the line of reflection is a perpendicular bisector, and that the points are equidistant from the line of reflection. Okay, so the third step is we are going to count distance and reflect. And when I say reflect, I don't mean like we're going to look inward at our lives and think about things, which is a good thing. Don't get me wrong there, but we're not doing it at this time. What I mean is we are just simply going to count. So, first off, if we have a straight horizontal line, then straight vertical would be perpendicular. So that's an important thing to know, is that this needs to be perpendicular when we count. When you get into some more advanced reflections, which I cover in later sections, that is a little tricky, but not too bad when it's not a straight horizontal line or a straight vertical line. But those are the easiest, when it's straight vertical, straight horizontal, because you just go in the opposite direction. If the line is left to right, okay, this line of reflection left to right, then making a perpendicular, I just go up and down. If it's a line of reflection that goes up and down, then to make it perpendicular, I just go left to right. So it's easy when it's straight up and down. Okay, so sorry, I digressed from what I was doing. Notice how when I count to the line of reflection, I counted 3 units. Okay, so 3 units gets me down to the line. Now, what I have to do is if I'm reflecting, I know it's equidistant. So I know that it's going to be 3 units from this. And I don't normally draw the arrows this way. Usually I just draw the arrows again in the same direction. But I just want to show you that it's reflecting. There needs to be 3 arrows pointed towards the line of reflection if it is in fact a reflection. So my new point P is going to be P prime, and it's going to be right here. Why again? Let me just show you again, because this is 3 units. This needs to be the same measurement. So if this is 3 units, then this needs to be the same on the other side of the line, and that also needs to be 3. So if you count 3 down, you just got to keep going and count 3 more to get the new point of where it's reflected. And that's basically it. If you have a shape, basically just repeat the process for each vertex and then you're good. You don't have to worry about all the little individual infinite points on the line. Just do the vertices and then you can draw on the lines later. All right, let's talk about some properties. This is just for you to know. This isn't tremendously important, but the more you know. So our first one, properties of reflection, we have that it preserves distance. Reflections preserve distance. And we've already talked about that earlier. If we have a line right here all set, then it's also going to be a line over there. I'm not liking that. They're different sizes. So there we go. So it preserves distance. The second thing is it preserves angles. Oh, and I forgot to say, it preserves distances on the shape itself. So it preserves angles is the second one. So it preserves angles. So the angles are going to stay the same in the shape. So if we have this as a certain angle, it's going to be that. If we have that as a certain angle, it's going to be that. And same thing here. 1, 2, 3, 1, 2, 3. It's going to preserve the angles. And then the third property is each relationship only has 1 point. I said relationship, I mean each reflection maps only 1 point. Okay, we're not going ultra dimensions here with multiple planes and all this stuff. It just maps 1 to 1. So if we have 1 point over here, it maps only 1 point there onto that side. So just some properties for you to know. Not tremendously important. I think the application is going to be important here. But let's look at example 2 as an example. So we have graph points -3, 4, 0, 1, and 4, 2. That'd be our first step. Plot the shape. All right, so our shape A is -3, 4, -3, +4. Sorry, I almost went down. -3, +4. There's our first one. Then we have 0, 1, and then we have 4, 2. So I'm going to connect the dots here just so we get an idea of what this shape looks like. And the other thing I'm going to do is I'm going to change the line so that it's dotted, just so we can see that it's the pre-image. Okay, so that's the pre-image. That's for you guys to know that that is the pre-image. All right, so we're going to graph and label this. These are the instructions. This is what it's telling us to do. This is the transformation. First thing you'll see, you recognize that this is reflection. Second thing you'll see is this is the line of reflection. And then we have the pre-image, which you've already drawn, pre-image. So what is our step? Our step 2 is draw the line of reflection. Well, it's the y-axis. Now, if we wanted to write that in terms of an equation, the y-axis is the same thing as x equals 0. That's a tricky thing to know. The y-axis, is the same, synonymous with x equals 0, and the x-axis is synonymous with y equals 0. So that's a little tricky. That can be tricky. So just make sure you, I guess, commit that to memory if you don't already know these two things, okay? Very important. So we have y, x equals 0, triangle A, B, C, but you can just use the y-axis. That's fine too. Let me go ahead and draw that. So here's my line of reflection, and I'm going to style it just so that it's dotted so we can see the difference, or dashed. This time it's dashed. Dotted was the pre-image. Now, what do I do? Well, what I'm going to do here is I'm going to count the distance to the line of reflection. So notice how it's a vertical this time. So perpendicular to it, I need to count perpendicular to my line of reflection, is going to be horizontal. So I go straight horizontal, left to right, and I see that that one is 3 units. What I like to do is I just, okay, if I need to maintain distance, oops, undo. If I need to maintain distance, then I'm just going to count 3 more over here. And I'm going to plot my new point right there. So if I do 3 to the line, then I have to do 3 on the other side of the line. Okay? Then I'm going to look at this guy. Look at this guy over here. This time he's on the right. I still mirror it, just like I did before. Okay? So it's not synonymous with the mirror in that, because it's kind of going through the mirror in this case. So you still have to follow those rules. So here was 4. I'm going to count 4 more over here. 1, 2, 3, 4, because these are perpendicular. Okay, make sure it's perpendicular, and it is, because I'm counting straight left to right, because the line is of reflection is straight vertical. And there's my second point. Oh, I didn't label my points. That's a bad move on my part. So first I should have labeled the points. This was A, B is here, and this is C. So the ones I've done so far are A prime and C prime. I have not yet got to Optimus prime. Oh, sorry, I meant B prime. Now look at B. B is right on the line, so its distance is 0. So if I'm going to plot my point, then I need to be distance of 0 from the line. So I just put it right on top of it, and that is going to be my B prime. My B prime is in the same spot as B. And what I'm going to do now is I'm just going to connect my lines. Okay, so there's my lines connected, and I have finished. That's it. That's what it looks like. So if you can look at the green and the purple, you can see that it's perfectly reflected, and that's all there is to it. There's my triangle A prime, B prime, and C prime. So that's like an intro to reflections. Hope you guys learned something. Be sure to stay tuned for future reflection videos. There's actually a 9.2 part 2 that you'll need to watch right after these messages. Thanks for joining me.